So mainly, there's two main big topics that we've done on this AP packet. A bunch of the stuff in the beginning, not every problem, but a bunch of them had stuff about tangent line, okay? You had some other stuff about, show that the second derivative, and you got some nasty, funky stuff there. Number 4, show that the derivative is this, or find the derivative. They give you some weird stuff with derivatives, okay? But a big, huge key point that comes up again and again on the first part was tangent line. All right, what comes up on the second part? This is 9 through 13, or 9 through 12. 13 is one other thing that we'll do, is implicit differentiation. Implicit differentiation, again, this was 2.7 and 2.8, is when we did stuff that was, or 2.8 and 2.9, I can't remember. Anyway, earlier in this chapter, was when it's not functions, okay? You've got an x and a y, you can't solve for y, so you have to follow, again, huge key idea here, that this xy squared, when I take the derivative of it, it is x times y squared. And when I take the derivative of that y squared, this is the huge thing they're testing you over, you have to follow chain rule. What I typically do is I underline the 2 to make sure I remember that it's product rule. And then sometimes I circle it to indicate to my brain, hey, remember to do chain rule there. I know you can barely see that. It's not very big print. Now, let me tell you this while we're going over it. There are 2 ways that AP scores these. So here's a full AP problem. It is 9 points on this one. And there's a reason I chose this one to be the example problem that we're going over. But sometimes they give you 2 points to find the derivative with implicit differentiation. Sometimes they give you 3 points. They give you 3 points if they don't tell you what it is. They give you 2 points if they tell you what it is, and all you got to do is show the work for it. All right, so there's 2 different ways you're going to see that same question. It's a very, very common question on the AP test, and there's 2 different ways they ask it. Either show and give you the answer, it's 2 points, or 3 points if they don't give you the answer and you got to find it. All right, so here we go. Of the first one, product rule. So derivative of the first part, derivative of x is 1. Leave the second part, y squared. All right, now I got leave the first part, so plus x, derivative of y squared. Okay, so do you remember, this is going to be on your mastery exam, it's going to be a multiple choice question, and it's going to be on a bunch of questions right here a row on the AP test. What is the derivative of y squared? Very good. 2y, y prime. Okay, got to know it. That is definitely going to be on the AP test. Okay, now minus. All right, let's have you guys practice what I just did. See if you can do it with this one, because that's another product rule that's very, very similar to what I just did there. But have you kind of activate that background knowledge and get that done. Let's check it. So on this one, I did. Now notice what I'm going to do here when I underline these two. I'm going to say negative x to the third is my first thing, and I'm going to say y is my second thing. Product rule between those two. See how I underline that negative? Because it'd be really easy to forget it on the second part. Derivative of the first one is 3x squared. Leave the second one y. And then it'd be really easy to put a plus sign here. But if you highlighted that it's negative x to the third, all right, with that plus sign you will write minus x to the third. The derivative of y is y prime. It'd be very easy to forget that negative sign right there. Okay? So again, the hint that I'm giving you is underline it that way to shows you that first item is a negative x to the third. All right? It is equal to, what's the derivative of 6? Derivative of constant is always 0. Don't put 6. Every once in a while people put 6 there. Okay? Now we should be in this repetitive motion, and we've already practiced this. Keep all your y primes on one side, move everything else to the other side. So this is, see, I'm going to write this 2xy y prime minus x to the third y prime equals 3x squared y minus y squared. Since all my y primes are on one side, I'll be able to factor them out. Y prime comes out, so I do not have them here anymore. All this stuff is multiplying y prime, so I'm going to divide by all that stuff, and I got my answer. Y prime is 3x squared y minus y squared over 2xy minus x to the third. That is exactly, and I mean piece by piece, I happen to do it exactly like they asked for. If I had something reversed where this is like negative x to the third plus 2xy, it's not wrong, but I would always, if they say show that, I would rewrite this so that it matches up with that exactly. I mean, every piece with every sign matches up. And I got it. Alright, part B. There's part A. Part B. Find all points on the curve whose x-coordinate is 1. Okay? So, you're telling me to figure out where my x-coordinate is 1. That means that I go back to my original equation and I replace all my x's with 1. So it's 1 times y squared minus 1 to the third times y equals 6. Okay? Algebra 1 stuff. Y squared minus y minus 6 equals 0. How do you solve that? Yeah, factor. Y minus 3, y plus 2. So y is 3 and negative 2. So to answer their question, find all the points on the curve whose x-coordinate is 1. Well, one point would be 1, 3. Another point would be 1, negative 2. Out of 4 points, that's probably 2 of your points right there. Okay? But I'm not done with this one. Write an equation for the tangent line at each of those. Well, what do you know? We just practiced tangent line on a bunch of problems in a row. Let me bring up this little fact real quick. 1, 3, and 1, negative 2. Think about that real quick. If I go forward 1 and up 3, and forward 1 and down 2, those are 2 points on my curve. This thing doesn't pass the vertical line test. And again, I knew from the beginning that it wasn't a function, but I'm just pointing that out. Okay? Those are on the curve and it doesn't pass the vertical line test, so this is not a function. That's why we have to use implicit differentiation, so that that's my instantaneous slope, my derivative, instantaneous slope anywhere on this curve. Alright, so here's my answer for 1, 3. I mean, I can give you part of the answer. It's just y minus 3. I don't know what my slope is, x minus 1. Now what I've got to do is I got to go figure out what my slope is at 1, 3. Well, my slope is that whole dy dx, or my derivative, evaluated at 1, 3. I'm just, you wouldn't have to write all this stuff on the AP test, but I'm trying to be very, very clear where all this comes from, and to be very clear on where I'm plugging it in. I'm plugging in 1, 3 into dy dx. So that is 3 times 1 squared times 3 minus 3 squared all over 2 times 1 times 3 minus 3 to the third. All I did was I plugged in 1 and 3 for x and y into this. Okay? Well, what is 3 times 3 minus 3 squared? 0. Doesn't even matter what the bottom is. If the top is 0, I get a 0 there. I'm going to take that 0 for my slope, throw it back into point slope form, and I'm done. Now, by any means, you could, if you want, simplify this. You could say y minus 3 equals 0, or y equals 3. Nothing's wrong with that. If it's a multiple choice answer that they're looking for, they're probably going to write it as y equals 3. But shoot, I'm done. I'm just going to leave it like that on a completion problem, and they will give you full credit for that. Least amount of work possible to do everything that they're asking for. Alright, so here's what I want you to do. I want you to follow the same procedure for the 1, negative 2. Get practice with what I just did there. Plug in 1, negative 2 into your derivative. Figure out what your slope is, and write your answer in point slope format. So there is the final answer, but you go figure out the slope. Okay? Yeah, this should be a 1 cube. I was looking back at this. It should be a 1 cube, my fault. Should have been a 1 cube right there. This should be a 1 cube right here. Now again, it didn't end up affecting me because I got 0 on the top divided by anything is just 0, but it will affect you in this one, so be careful with it right there. Okay, so that gave me, what do I got here? Negative 6 minus 4 is a negative 10. I've got a negative 4 minus 1 is a negative 5, which is a 2. So there's your final answer. Okay? Got it. 1 point for this one, 1 point for this one. There's your 4 points. Did you plug in 1? Did you get those answers? Did you get this? And did you get this? Okay? Just leave it in that form and you are done. Okay. Long problem, but here's what you need to keep in mind. You're going to practice this stuff for a long time, and you get 15 minutes. When the actual test rolls around, you will get 15 minutes for each completion problem. Okay? It's a good amount of time after you've been practicing this stuff for a while. I have not been stressed as far as time goes for the completion. There's part of the multiple choice that is going to be a little stressful in time. Completion should be alright. Alright, finally, last part, and this is why I'm doing this one, and again, why I want you to see the grading scale of it. Oh, I'll go back to black here. Alright, part C. Find the x-coordinate of each point on the curve where the tangent line is vertical. Alright, so let's think about that. Now, I taught this a few days ago when we did this whole implicit differentiation. We talked about horizontal tangents and vertical tangents. Okay? How do you get a slope of vertical? It does not exist. Good. And how do you get that? By 0. So, the key here with a vertical tangent is that the bottom is 0. If it said horizontal tangent, the top would be 0. Vertical tangent, the bottom is 0. So in other words, this stuff, I want to know where my slope is 0 on the bottom. Because then, no matter what's on the top, take 1,000,000 divided by 0, undefined. I want to know where that stuff's equal to 0. So, 1 point for just, do you know that setup? Did you take 2xy minus x to the third and set it equal to 0? Do I know that that's what I need to do? Alright, second point, solve that sucker. Take out an x. 2y minus x squared is 0. Well, that's a little weird. So, x equals 0 would produce a vertical tangent. Or, 2y minus x squared would equal 0. Here's the weird part. Didn't mean to do that. Solve for y. Y is x squared over 2. So whenever my y value is equal to the x value squared over 2, that's where I get a vertical tangent line. Okay? Well, that's not an answer. It said find the x-coordinate of each point on the curve. What I can do with that, though, and this is where I'll show you this one, because some of this stuff is problem solving and critical thinking in the middle of the AP test. I've said this so many times. They're going to throw things at you that you've never seen before. I cannot possibly show you everything that's going to be on the AP test at all. Now, the rest of this is just algebra, but it's weird, and that's what they do to you. I've taught you the calculus. Now can we solve some weird problem with your algebra background? So if this is the relationship that I have, and I've solved for y, I can take this and I can throw it back in the original problem. This is one of those systems of equations from Algebra 2, but it's a systems of equation on crack or something, I don't know, steroids, something ain't good for you, alright? So you're taking this stuff and you're plugging it back in the original. So if I take x times x squared over 2 squared minus x to the third times x squared over 2 equals 6. Now I've got this is solving a systems of equation by substitution. And again, this is something that AP kind of likes you to do. Now, it doesn't always get this nasty. This is why I chose this as my example problem. I wanted to show you about as bad as it can get, but they really do use this on, not a regular basis, but often for their completion problems, that you got to do some kind of substitution. Solve for one variable, and then plug it in over here so you can actually get the value of the other variable. This is something that we are capable of solving. It's really not that bad. Looks pretty nasty at first, but it's really not that bad. This is x times x to the 4th over 4 minus x to the 5th over 2. You got some options here, but what I would do is combine these to x to the 5th over 4 minus x to the 5th over 2. Well, what's a 1/4 minus 1/2? 1/4 take away 1/2. What do you have? Negative 1/4. Alright? Well, now it's starting to look alright. Now we should be fine to solve it. What do I gotta do to get x by itself? Multiply by -4. Good. And then how you get rid of that fifth? Fifth root. Made it looks nasty, but okay. I'm telling you, AP is going to make you see some just funky, weird stuff. And they want to know that you can do the math and algebra and calculus behind it. You're going to get some answers that look like this. Negative fifth root of 24. I mean, that, I don't know what that is off the top of my head. You're not supposed to know what that is. But can you get to the point that even though your answer is just weird and that is real world stuff. When you go into engineering, there are not many times that popping a number like 2. You're going to get fifth roots of 24 in the real world. And that's what they're after. Okay? So, here's how your scoring would work on this, and this is where I kind of want to put you at ease. Not at ease, but tell you this. Still need to be a little worked up, okay? With 3 points on it. First off, did you just know to take the bottom and set it equal to 0? They give you 1 point for that. Okay? They give you a second point for getting to this point. Did you get a 0 and did you get this stuff? Y equals x squared over 2. And then finally, this is the weird part. Did you take that, plug it back into the original, and actually get this answer? So you could get 2 out of 3 points or 8 out of 9 just for kind of starting in the right direction and trying to do something here. Even if you didn't realize I can plug that back in the original and come down here and get this weird fifth root of 24. Or if you just did some algebra wrong in the middle of it. But I do want to point out a few things that this is where we're going. We got a little ways to, before we got to get here. But if you're getting 6, 7 out of 9 every time on these, 9 out of 9 is hard to do on these problems. Okay, you will miss 1 or 2 points in the middle here, and that's absolutely fine. You get 7 out of 9 on all of your completion problems, you're getting a 5 on this test. Your name's going on the board, in the hall, and you'll be up there forever as a math all-star. Okay. All right, there you go. So again, I picked this because I wanted to show you some of this is as bad as it can get. But with that in mind, now I think you can go and do a bunch of the next problem.